So today we are going to be solving radical equations. So you should have your notes in front of you while I am going through these problems, and you should be working out these problems as well. I recommend that you pause after we do the first example. Try example B and example C on your own. So pause the video, try working it out, and then watch me work it out and see if you did it correctly. So we're solving radical equations. We're going to solve equations that have one radical, and then we're going to solve equations that have more than one radical, have two radicals. And remember, a radical is a square root or a cube root. So if there's one radical in the equation, you want to get that radical alone on one side of the equal sign. So if you look at example A, I have one radical in my equation. I need to get it alone. I need to get rid of anything that is being multiplied to the radical on the outside, or anything that is being added or subtracted to the radical on the outside. So I need to get rid of this 3. This is 3 times the square root of 2x minus 1. So to get rid of multiplying, we divide. So we are going to divide both sides by 3. Divide both sides by 3. So they cancel. I have the square root of 2x minus 1 equals 2. So that's step 1. Get the radical alone. Step 2. The way we get rid of a square root, is we square both sides of the equation. A squared cancels a square root. A cube cancels a cube root, and so on. So we are going to raise each side of the equal sign to the root of the radical. So we're going to raise this side to the second power and that side to the second power, because remember, what you do to one side of the equation, you have to always do to the other side. Well, step 3 is to simplify and solve. A squared cancels a square root. So I'm left with 2x minus 1, and then 2 squared is 4. And so now I just finished solving. Add 1, 2x equals 5, divide by 2, we get x equals 5/2. That is how we solve an equation that has a single radical in it. So now why don't you pause the video and try working out B and C on your own. Notice that C is a cube root. So when you get to step 2, you're going to have to raise both sides of the equation to the third power. So in problem B, I need to get rid of the 4. So I'm going to divide by 4. So 12 divided by 4 is 3. Then I need to get rid of the square root. To get rid of the square root, I square both sides of the equation. 3 squared is 9. When I square a square root, they cancel each other out, and I'm left with what's underneath, which is 2x plus 1. And then I finish solving by subtracting 1 and dividing by 2, and I get x equals 4 as my answer. Problem C. I need to get rid of the 3 because it is on the outside of the radical. This is adding 3, so to get rid of adding, I will subtract. So I have the cubed root of 2x minus 1 equals 4. My cube root is by itself. To get rid of a cube root, I need to raise both sides to the third power. That cancels the cube root, so I have 2x minus 1. And 4 to the third, well, 4 times 4 is 16. 16 times 4 is 64. Now I need to finish solving for x, so I will add 1. So 2x equals 65. Then I will divide by 2. So x is 65 over 2. And you can just leave your answer as a fraction like that. Obviously reduce them if you can reduce them. So now if you have more than one radical, you want one on each side of the equal sign. So they should already start out that way, but if they don't, add or subtract to move it to the other side of the equal sign. Then we're going to raise each side of the equal sign to the root of the radical to cancel the radical, and then we'll simplify and solve. So if you look at A, these are both cube roots. They will never be different, like you won't have a square root and a cube root. They will be the same roots. So they're on opposite sides of the equal sign. So I can just raise both sides to the third power. The third cancels the cube root. So I'm left with 3x plus 1 equals 2x plus 3. And now it's just a regular equation to solve. So I will subtract 1. 3x equals 2x plus 2. Subtract 2x. And I get x equals 2. That is my answer. Now if we take a look at b. For b, yes, I have radicals on both sides of the equal sign, but this particular radical has a coefficient in front of it. I cannot divide to get rid of that coefficient like I did up in a and b. I was able to divide by 4 and divide by 3 because there was no radical here. It was just 6. But in this problem, because it's another square root, I cannot divide by 2, so I'm just going to have to leave it alone. So I have a square root on both sides, so I will raise both sides to the second power. These cancel, and I'm left with x squared minus 4. And here's the tricky part. I have to square both of these. So I have 2 squared, and I have the square root of 3 squared, because I'm distributing that squared to both of those terms. So 2 squared is 4, and then when I square a square root, they cancel, and I'm left with 4 times 3, because this is multiplication. So that leaves me with x squared minus 4 equals 12. Finish solving. Add 4. X squared equals 16. Square root. X equals the positive and negative square root of 16, which is 4. Those are your answers. Now you have a worksheet that you will work on today, and then you will get another worksheet tomorrow to practice solving these radical equations. Have your notes in front of you while you are working on it so that you can follow the examples that I have if you need help.